Hello everyone, my name is Roy Jafari and I would like to welcome you to another video of data mining series. In this video, we are going to talk about what is prediction. Prediction is one of the most important and most famous data mining tasks that can predict the future. There are different understanding of this term prediction. So we are going to first understand what prediction is and what prediction is not, and then we are going to look at an example that is going to help us understand the design and solving of these prediction tasks. All right, let's get to this slide. Okay, so the outline we are going to have in this video, we are going to first talk about what is not prediction. Then we'll talk about what is prediction, and then we will talk about a simple example that is going to be very helpful for your understanding of a prediction task. Then we are going to look at two famous algorithms that are at the end of the spectrum of many different characteristics of these algorithms, and we're going to see how these algorithms would approach solving or doing the prediction tasks in this example. Okay, so what prediction is not? When we talk about prediction, there are many terms that might come to mind: forecasting, prediction, regression analysis. So it is very important to understand when we talk about prediction in the context of data mining, we mean a very specific design of the data environment in a way that a prediction happens, right? So for all the intent and the purposes of the data mining, what we mean prediction is a different story than the forecasting. In the next video, we are going to talk about what forecasting is and how it is different from prediction. But for now, I want you to remember that forecasting is not prediction. So always remember this: forecasting and prediction in the context of data mining, they are completely separate entities. How about regression analysis? Regression analysis is perhaps the oldest and most reliable and most well-researched technique for prediction. So it's really hard to say if regression analysis and prediction are the same or different. In reality, everything that we do, prediction with the most state-of-the-art algorithms, in their essence, they are sort of a regression analysis in which we connect the independent attributes to dependent attribute. But then again, there are a couple of different algorithms that they are actually regression within, literally regression to the sense of the term regression, because they use regression equation and those types of mechanism behind the scene to estimate the coefficients. So, I'm not going to draw a line between them here, but, prediction is basically connecting independent attributes and the dependent attributes. So, in any decision-making environment, if you have a set of independent attributes and one dependent attribute or more, in most cases, you're going to have one dependent attribute. It is possible to have more, but let's go just with one dependent attribute. If you can make a connection in such way that the patterns in your data support a connection between the independent attribute and the dependent attribute, then this pattern that you have found can be put into use for prediction. And this whole thing of finding these patterns and packaging them for later use is called prediction. So for example, let's look at this example. For example, Mississippi State University would like to predict the number of student applications in the near future. By the way, Mississippi State University is an excellent school where I got my PhD from. Go Bulldogs. But that's beside the point. Mississippi State University is is a unique university where a lot of the events on the school revolves around the sports and those events that are very exciting and attract a lot of students. So here, after some forethought and analysis, we have understood there are two independent attributes from this decision-making environment that can predict the dependent attribute that we are interested in. And a couple of other terms that we use for dependent and independent attributes. For independent attributes, you might hear the term predictor, predictors. And for the dependent attributes, you might hear the term target. These are exactly the same thing, but they are these are different terms that they are used for the same thing. So the target that we want to predict, we do have seen and we think that there are some possible connection between the previous year football performance, and the average number of applications in the last 2 years. With these two information, with these two predictors, we want to be able to predict the target, which is the number of applications. So how does this would look like in terms of a data set, right? So when we have a data set like this, that we have, these independent attributes, right, for year 2006 all the way to 2021. So these are our predictors, and this is our target. Now, because we have these data objects and data points, so these are all our data objects, right? So these are all our data objects. Because we have all these data objects, now we can try to find some patterns between these independent attributes and the dependent attribute. And when we do find those patterns using an algorithm, so an algorithm comes in and whatever mechanism they have, they try to come in and find some meaningful patterns from this data. Then once we found these meaningful patterns, then a new data, which is for 2022, that Mississippi State University hasn't seen, can come and use these patterns that the algorithm has found, therefore come to a prediction number. And that's the whole prediction task or prediction mechanism for data mining. So pay attention. Like I said, not any other methods of doing some prediction. We have subjective methods. Someone who has been in the system might have a prediction. That is a prediction in itself too. But what we talk about prediction, when we talk about prediction in data mining context, is that the recognition and providing the independent attributes that can have some patterns, some meaningful pattern with the dependent attribute, that we can find these patterns and later use them. So this connection between independent attributes and dependent attributes are the key for understanding what is a prediction task. So now let's look at how different algorithms would go about this this prediction task. So first, we are going to see how linear regression would solve this task, and then how artificial neural network, or MLP in this case, is going to solve this task. So let's take a look at it. So the path from linear regression generic model to this model that has the potential to solve or capture and package the patterns in the data for future prediction comes from this design of this equation, right? So this is the linear regression. So we say our target, right, is equal and beta 0 coefficient plus beta 1 multiplied by the first predictor or independent attribute plus beta 2 multiplied by second independent attribute. SMA2 is a code we've given to the previous number of years here, average number of applications from last 2 years. So this is a code we have given to this name. All right, so this is our model, and then once we have this model, we go back into the data. We will go back to the data and try linear regression tries to find these betas to best estimate this relationship. So after we use linear regression, at this point you don't want to worry about how linear regression will go about this. Comes to estimate these betas as these numbers, right? So once we have these betas as these numbers, now this equation will allow us to do prediction, right? So for example, here I have the 2022 data, right? So I can say the number of applications for 2022 is going to be negative . We'll get the number 16,777.8. So this is the number we get. Alright, so how about artificial neural network? Do you remember, for us to be able to connect the independent attribute to the dependent attribute, we used an equation. Artificial neural network, or in this case, multi-layer perceptron, MLP. MLP is one of the variations of artificial neural network. It's perhaps the most widely used one. So we use a network of neurons connection. We have input neurons, we have output neurons, and then we have hidden layers neurons. And all of these connections will have a coefficient or a weight. And by changing these weights using a smart algorithm they call backpropagation, we come to a trained network that those weights make a really good connection from the independent attributes to the dependent attributes. So you have to see here the difference between linear regression specifically, and MLP is that linear regression is more transparent. Those coefficients that we saw here, they have meaning for us. If you look into those coefficients, we'll see that if the football performance increases, also the number of applications is going to increase. And how important the number of applications in the last 2 years have influenced the next year application, right? So these have meaning for us. But once the MLP here is trained, we don't have any of that. We're not going to have very quick intuition about what's happening in the network as far as us understanding the patterns among the data. But on the other hand, as linear regression is stuck with a simple linear equation, we do have that simplicity, but at the same time, if there are non-linear relationship between these attributes, we're not going to be able to capture them. But this predictor or this structure is more capable of capturing non-linear relationship. Before I end this video, I want to leave you with the fact that MLP, something that we will discuss in the later videos, MLP can be really designed in different ways, and there are a lot about how MLP must be tuned and then must be validated. There are a lot of things about it, but here you have a simple understanding of MLP and how we can put different algorithms here, right? I mean, the prediction task is very simple. The algorithm here can become very complicated. How we want to find the patterns among the independent attributes and with dependent attributes that can help us to go about this prediction task. Alright, until the next video.